So we're going to look at an example where we apply Prim's algorithm, and we're going to use the example that we did for the last algorithm. So it's this graph with cities on it, and it has weights on the edges. And here it tells us we're going to start Prim's algorithm. You have to have a starting vertex. So here we're going to start with Minneapolis. So we're going to start with this vertex up here. And again, we want to use a table to track our process through this algorithm. So iteration number, we're going to write the vertex added, the edge added, and the weight of that edge. So when we start the algorithm, we're told we start with the vertex Minneapolis, and there's no edge yet, so we're going to leave that blank. Now, the algorithm tells us we're going to look at edges that are connected to the vertex we have. So here, there are only two possibilities. I can look at either this one or this one. And you're going to pick the one of least weight. So I'm going to pick the one from Minneapolis to Chicago. So I'm going to add in the Chicago vertex. And the edge that gets added is Minneapolis to Chicago. It had weight 355. So I'm going to go back in now that I've added that weight, that edge in. I'm going to go ahead and color it blue so I know I added it, and I added Chicago. So now you're going to look for the next iteration of our algorithm. You're going to look at edges that are connected to the vertices we've already selected. So you still look at this edge, and then any edge connected to Chicago, and you're going to pick the one of least weight. So if I look at those four edges, the one of least weight is the 174. So I'm going to add in Milwaukee. So the edge that got it in, added in, was Chicago to Milwaukee, and it had weight 74. So let me go back to my picture now, and I'm going to add in that edge and that vertex. And we keep going until we've reached the right number of edges. So let's see, 3 here. So look at any edge connected to any of the vertices, Minneapolis, Chicago, or Milwaukee, and you're going to pick the one of least weight. So 262 looks like the least weight. That is Chicago to St. Louis. So we're going to add in St. Louis, Chicago to St. Louis, and it had weight 262. So let's go back now. Now that I've decided which one to add in, I'm going to add it in, Chicago to St. Louis. Okay, so then the next step, let's see, out of all of these vertices, look at any edge that's connected to these vertices. So there, there, and there. Which one has least weight? Well, 242 looks like the smallest, so from St. Louis to Louisville. So the vertex I'm going to add in is Louisville. The edge is St. Louis to Louisville. It had weight 242. So let's add that edge in now. So erase the ones I was considering. The one I added was St. Louis to Louisville. Okay, so now for our next iteration, we're going to look at the vertices here. This one, this one. Oh, sorry. Which ones are we looking for? One's connected to vertices that are blue. So that one, that one, that one. And then any coming off of Louisville. So you're going to look for one of the smallest weights. So 83 appears to be the smallest weight. So we're going to add that one in. So 83, it was from Louisville to Cincinnati. Cincinnati. Okay. And then let's look at our next one we can add in. Let's erase these arrows. So which ones are we going to consider? Again, any vertex, any edge coming off of a blue vertex. So this one's still up for consideration. Any off of Louisville, Chicago, or Cincinnati. So here, what's the smallest weight? The smallest weight is 151 off of Nashville. So you're going to add in Nashville. The edge that gets added in was from Louisville to Nashville, 151. So let's add that edge in. So we're going to erase here. We still have to keep going because not all of the vertices are here yet. So I think we just need to do one more iteration. You're going to look at the edges that are connected to a blue one that aren't yet included. So this one, this one, this one. And you're going to pick the one of least weight. So 230 appears to be the least weight. So that is the one that gets added in. 230. It's Cincinnati to Detroit. We added the city Detroit. So let me add in that edge. Now we've touched every single city, so we can stop now. And this is the minimum spanning tree we get when we use Prim's algorithm and the starting vertex being Minneapolis. If you compare this with the one we got from Kruskal's algorithm, you'll see that we have the same edges. They just got added in a different order. And so this algorithm, it really does depend partly too on your starting vertex. Okay, so for Prim's algorithm, you have to have a starting vertex.